Okay, so in order to complete the problem with all this terminology, by the way, we need to say that FDSD is the cumulative cost from beginning of month T, which means the fourth month is this month here. So this is the beginning of the fourth month to the end, and so this will be for T equals. This will be for T equals. We'll start with 4 for the fourth month, the third month, the second month, and the first month. So we need to start with the fourth month, and it will be the demand is very important to know. So let's start with a blank page here. So we're going to determine F4 as 4. So what is the cumulative cost for month 4? And also the demand D4 is equal to 4. Everything is 4, I believe. Yes. So we don't know what the inventory could be at the beginning of the month. So let's start with the lowest level, that it's 0. And we need to provide 4 units. And we don't want to ever produce more than 4 units. So therefore, there really is no choice, because we don't want to produce for beyond the horizon, because we don't know if there's a demand beyond the horizon. So we would be, the cumulative cost would be then 3 for the setup, 4 for the production, and that would be 7. And we'll write here the X4 star will be to produce 4 units. And if we have 1 unit in inventory, we'll be spending, then we'll have 3 plus another 3. We'll have to pay 0.5 for the inventory, and that's it. So we'll have 6.5, and the optimum will be to produce 3. Same thing for if we have 2, it'll be 3 plus 2 plus 1. If we have 3, we'll still have to produce 1 plus 1.5, so 5.5. If we have 4 units in inventory, then we don't have to produce at all. So we don't have to have a setup cost. We don't have to have a setup cost. We don't have to have a production cost. So all we have to incur is the holding cost of 2. And so here we produce 2, here we produce 1, here we produce 0. And that's how we start the process. So this process is much more intuitive and logical than formally stating the Bellman equation. We're acting on a Bellman equation. We're in fact implementing this. We're just starting at the third stage, and there's nothing beyond we're starting at the fourth month, and there's nothing beyond the fourth month, so this term will be 0, and this is where we are. Then the next thing is we have to deal with the third month, and the third month of demand is 2. So we will now deal with the third month, F3S3, and the demand in the third month is 2. And we'll don't know how much we start off with. So let's start off with 0. So this time we can produce for both month 3 and month 4. What are the choices? Well, it'll be a minimization. And what are the choices of X? Well, we can either produce no units. No, that's impossible. We have to produce at least 2 units. 2 units, 3 units, 4 units, 5 units. That's the most production we can have. And if we produce 2 units, the immediate cost will be 5. And let's just record all the immediate costs, and then we'll look at the future costs separately. This will go up by 1. 2, 3, 4, 5. 2, 3, 4, 5. So we're fine. And now if we produce 2, we will have 0 left for the next month. So we need to look back. If we have 0, then the cost is 7. And if we look here, they come down by half a unit until we get to 5.5. So this will be 6.5. This will be 6. And this will be 5.5. And we then take the lowest of these is 12. And let's mark here the X3 star will be to produce 2 units. So if you have none in inventory, if you have 1 in inventory, we can produce 1 and 2, 3, 4, 5. Let's be careful here. If we produce 5 and we have 1 inventory, that's 6 minus 2 is 4. That's fine. Let's do the same thing as we did last time. If we produce 1, it'll be 4 plus 5. Oh, this time we have to remember to account for the holding cost. So it'll be 4.5 plus, and then 5.5 plus, 6.5 plus, let's go down here, 7.5 plus, 8.5 plus. If we produce 1 unit, then it will have 0 again. It will be 7, and it will be 6.5, and 6, and 5.5. But then we have to be careful. I believe it then comes down immediately down to 2. And so this gives me 11.5, and then it grows. And this gives me 10.5. So that's the lowest one. And so the optimum is to produce 5. If I have 2, this time I can produce 0, or 1, or 2, or 3. Let's be careful. Or 4. 4 and 2 is 6. Minus 2 is 2. I can't produce 5 because if I produce 5, then 5 plus 2 is 7, minus 2 is 5. I cannot carry over 5 units in inventory. There's not enough room. Okay, so if I produce 0, I still have to pay the holding cost. If I produce 1, then I have to pay 4. 4, that will be 5. And this will grow by 1. 0, 1, 2, 3, 4. Oh, that's the end. And if I produce 0, then I will have 0. That will give me again 7. And this comes down by half. And after 5.5, it comes down to 2. So this is 8 and this is 10. And this grows. So therefore, the optimum here is 8. And not to produce any. If I have 3 in inventory, the min is over. I can produce 0 again. 1, 2, 3. I believe 6 minus 2 is 4. I cannot produce any more. And here, if I produce 0, I have to have 1.5 for the holding cost. If I produce 1, it'll be 4, 5.5 plus 6.5. So 0, 1, 2, 7.5. And this will be plus. The rest of the period will be, if I produce 0, 3 plus 0 is 3, minus 2 is 1. So I'll have 1 left in inventory. So the lookup here is 6.5. And then it's 6, and then it's 5.5, and then it's 2. So this is 9.5, and this is 8. So this is 8. So it's cheaper to produce none. And F34, that'll just be the minimum of 0, 1, or 2. Otherwise, I'm overloading my inventory. And this again is now 2 plus. It'll be 1 will be 4 plus 2 is 6. And 7 plus. And if I produce 0, I will have 2 in inventory. 2 in inventory gives me 6. 5.5 and then 2. That gives me 8 versus 9. That gives me 8. And the optimum is to produce none. So we're down to there. Let's take a break.